Guys, welcome to Concept and Coding. This is Shreyansh, and today in Spring Boot we are going to start transactional annotation. But before that, I would highly recommend you to watch these two videos. The one is the concurrency control, which I have shared in the HLD playlist, and another is the Spring Boot AOP, which we have just recently covered in the Spring Boot playlist. Okay, so if you already know about these two concepts, then we are good to go. And let's start it. So one thing before we start, we have to understand about critical section. So it's a very simple critical section definition. So it's a code segment where shared resources are being accessed and modified. Okay. So now let's say that this is my shared resource. So a cab. Okay. So in DB, let's say that this car has ID 1001 and currently status is available. Now there is a code segment where we are accessing this shared resource and also trying to update it. Okay, so that's why it's known as critical section. So now what happens is when multiple requests try to access this critical section, data inconsistency can happen. Now let's say that 4 people are trying to book a cab parallel. So now let's say that 4 requests comes here in the critical section in parallel. So all will read car with 1001. Yes, they will all read successfully. If status is available, yes, current status is available, update it to book. For all 4, they will like your car is booked, your car is booked, your car is booked, your car is booked. If critical section is not handled properly, right, then during multiple requests, data inconsistency can happen. So what is the solution? The solution is usage of transaction. The transaction helps to achieve asset property. We like during first year, I think, or second year, we all have studied asset property in the DB, right? So we just to remind you that the first A in the asset is atomicity. Atomicity says that in a transaction, if any operation fails, the entire transaction will get rolled back. What does it mean? Quickly, let's say that in a DB, A has 10 rupees, B has 20 rupees. Now this is your transaction. In transaction, let's say you want to debit A 5 rupees, you want to credit B 5 rupees. This is a particular, let's say, transaction 1. Okay. So now what atomicity says that first, these are operation 1, operation 2. Okay. So let's say the first operation executed, you debited A. So now it would be like 5 rupees. Now during credit, some failure happened and this operation got failed. The credit operation got failed. So as per the atomicity, if any operation fail, the entire transaction will get rolled back. So entire transaction, whatever the operations are there, previous operation will get rolled back. So means this debit operation which got success will also get rolled back. So this, instead of 5 rupees, it will again goes back to 10 rupees. Okay. So that's what actually lead to consistency, which says that before and after the transaction, our DB should be consistent only. So my DB was in consistent state, 10 rupees and 20 rupees, right? A and B. After running the transaction, right? Whether it's a successful or failure, doesn't matter, right? If it is a success, my DB state would be, A would be, let's say, 5 rupees and B would be 25 rupees. So this state of a DB is also consistent. If there is a failure, so again my DB state would be consistent. Okay. So this property consistency says that no matter after and before the transaction, my DB should be consistent only. There should not be any inconsistency like, okay, the debit got successfully happened 5 rupees, but credit doesn't happen. So credit is still 20 rupees. That is inconsistent state. Okay. So both are linked to each other. Then there is something called isolation. Isolation says that even if multiple transactions are running in parallel, they do not interfere with each other. So this is just one operation. right? You need to debit A 5 rupees, credit B 5 rupees. This is just a one transaction. There could be, let's say, multiple transactions running in parallel. There could be another transaction like debit A 2 rupees, credit B 2 rupees. There could be another transaction, credit A, debit B, something, X, Y, something. So what I'm trying to say is that multiple transactions can run at the same time, but they will feel like they are running individually, independently, right? In an isolation environment, like nobody is interfering to each other. Okay. So now let's say that everybody wants to update A. Transaction 1, transaction 2, transaction 3, and if there are any more, all wants to update A. So transaction makes sure that only one of them will take a lock on this and one of them only will update it. Okay, and once the lock is free, then only it will be given to another transaction and then it will work. So internally transaction make a proper sequence. Even though from the outside world we all see that all transactions are running in parallel, but it's not, right? Internally transactions make use of locking and make sure that the operations are in proper sequence manner. So each transaction feels that they are running in an isolation and no multiple transactions interfere with each other. And the last one is durability, which says that once your transaction, let's say this transaction, done its operation and it done commit. Now once the commit is happened, right, this data is persisted. Means now even if your system crash, this data should not get lost. Okay, so that's what durability says that. And all this atomicity, consistency, isolation and durability guarantee is provided by transaction, and that's why it is very popular during financial kind of applications. All financial applications mostly use which DB which provide this asset property. Okay, so generally this is like you begin a transaction, then you have your operations, then if all operations got success, you do commit, means you persist it into the DB. Else, if any failure, your rollback will happen, right? Rollback of all transactions and you end the transaction. So you have to do this. You have to do this. And now understand that in your application, let's say you have 100 methods. You have 100 methods, or I would say that 1000 methods. So let's say that you have 1000 methods where it is actually touching the DB. Okay, so let's say that this is update user. So it is actually touching the DB, right? Update bulk user. This is also actually updating the DB. Update user by ID, something. This is by email ID, something, different flavors, right? So all these are actually internally touching the DB. So you have to use this transaction for each. Now here if you see that your actual business logic is this only. Which one is your actual business logic? Actually this. Debit from A, credit to B. But here if you see that the lot of things you have to do just for the transactional, just to achieve the asset property. Begin, if all success, commit, else, rollback and transaction. But if you focus this red only, this is actual your business logic. Rest is all the verbose, right? This is, and if you see that there's a lot of duplicate you have to do. You have to do in this method, this method, this method. This is just one class. If there are hundreds of class, multiple methods, in all methods you have to put begin transaction, end transaction, if all success, commit, else, rollback, and then you have to put your operation. So this can be simplified through @transactional annotation in Spring Boot, right? So in Spring Boot we can achieve this through this annotation. So if you want to use this annotation, you have to add certain dependency. So this two dependency you have to add. The first dependency is like depend upon your which DB you are using. So let's say if you are using relational DB, then data JPA works fine, right? From this data JPA you can get at the rate transactional annotation, right? If you are not using relational DB, you are using NoSQL, because there are many NoSQL DB which also provide transactional support. So this dependency will get changed depend upon the DB which you are using. Okay, because you need at the rate transactional annotation, but it is coming from which dependency depend upon the DB. And now since DB got involved, you have to use a particular driver also, database driver also. So this is the second dependency you have to add. So in the POM, you also have to add database driver, right? And in application.property, you have to provide it username and password also. So this database driver, I haven't explaining you here what is the dependency and what things you have to put in application.property, because in the next topic after @transactional, we will cover this in depth. For now, like whatever the DB you are using for learning, right? You can just check what is the database driver dependency in Spring Boot documentation. You will get that, add this into the pom.xml, right? So that will works out. But this two dependency you have to add. And also this is optional, right? @enable transactional management in your Spring Boot application class main, where you are actually the main method is there. This is optional, because even if you don't write, I told you that Spring Boot automatically configures so many things for us. So it will add it for us, even if you don't write it. But just for mentioning that this is also required. Let's say that somehow Spring do not add it. Let's say what would happen? Then in whatever method you have put @transactional annotation, right? That will not be read. So it's like we have to enable the transaction management actually, right? So with that, once this available, Spring Boot scan for and look for @transactional specifically. But generally it's not added. It's automatically added by Spring Boot. Just a heads up. Okay. Now @transactional property can be applied at class level and at method level. If you applied at the class level, then it will automatically get applied to all the public methods, but not at the private method. Okay. And if you are using at the method level, it will get applied to only particular method only. So now you are using transaction, so only update car. Now all this is now your critical section kind of. So all this code inside this is now your critical section, right? And it would get handled through like begin transaction, right? All your business logic, right? And if any failure inside this operation, rollback will happen, and after all successful, commit will happen, right? This will, but not for this, because this is method level. Okay. So now transaction management in Spring Boot uses AOP. That's why I told you that AOP is the first prerequisite which you should know, because here you have to know about point cut and advice, which we have explained in AOP. Otherwise you will not understand how transaction management actually works internally. So what happened is, internally transaction management, this annotation, right, @transactional uses AOP. I told you the use of AOP, that AOP tells that, hey, you focus on your business logic, right? And all the verbose like duplicate code, I can take care of it. And now I already told you that here, this is all duplicate you have to write in each and every method, which is like duplicate, right? And only this is your business logic. You have to concentrate only this debit from A and credit to B. This all verbose is not actually your problem. So that's where AOP comes into the picture. So all this, now we are using @transaction only, but where is actually begin transaction, all success then do commit, else any failure do rollback, and transaction. Where all this where are all this code? It is present inside a particular aspect. Okay, I will tell you how it done, where it is present. But this verbose code is present there, and it has a placeholder join point. You already know that from the previous, right? In the join point, it invokes your method. Okay, so this is actually your business logic. So you focus on this method, right? Adding all these things, AOP will take care of it just by this annotation. Okay, so internally AOP, internally @transactional, what I told you, right? It uses AOP. AOP has point cut expression, and advice. Okay, so the point cut expression which it might be using is like this: @within and the path of this annotation transactional. So all the package, sub package, right? It will look for all the classes, and inside all the classes, all the method which has this annotation. If any method it found that it has @transactional annotation, the match will happen. The point cut expression match will happen. And when the point cut expression match will happen, you know that what generally happen is advice is run. Okay, the advice is run. And what is the advice here now? Once the point cut expression matches, in @transactional, it runs an around type advice. So there are three type of advice I told you: after, before, and around. So this around type is generally used for @transactional, right? And where is this advice method which is executed? It is present inside the transactional interceptor class, and this is your method which is act as an advice. Okay, so now here if you see, I am showing you the code. I have written a very simple controller class. Okay, this controller class I have given a name user controller, right? And the API is /API/update user. Okay, so /API, and I have created a method called update user, and this is the get mapping. Generally it should be post mapping, because I am trying to update. Okay, this is just an example, you can change it. So this is the API I wanted to expose /update user. Okay, inside this I am calling this dependency. I have put an auto wire on user. So user.update user. Now here if you see that in the update user method, I have used @transactional annotation. Okay, so now @transactional annotation brings me all the capability of ACID, right? So now how this actually works, where is begin and all these things. So you know that first point, when you start an application, the point cut expression will match the point cut expression. Let's say that this is the point cut expression. Okay, so using this point cut expression, it is able to see that yes, this is a match. A method has this annotation. That's what we are looking for. Now what advice has to run. Okay, so which is the advice? So inside a transactional interceptor class, there is this method invoke within transaction. This is nothing but an advice, right? So this will get invoked. So now here if you see that in this advice method, you will see that first it will create a transaction. Okay, then it will invoke your method, right? So your transaction is started like this: begin transaction is started. Then you can perform your operation. This is the place. It invokes your method. So this method will get invoked. Now you perform your update query. Now if any exception comes, what it will do is it will catch it, and it will, inside this, it will roll back. If you go inside this complete transaction after throwing, you will see that it would be doing rollback. But if there is no exception, everything is success, it should do commit. So if all success, it is doing commit transaction. Now, no matter if you have hundreds of classes like this, user, there is another table, let's say employee, there is another table, let's say like order, another class. You have so many classes, and each class has multiple methods, 10 methods, which is querying the DB, updating the DB, right? Modifying the DB. So you don't have to write all this in each and every method. You will just use @transactional. Now here, if you see that this code is used only at once, right? You don't have to duplicate it. And this is not even part of your code. This is coming from Spring Boot framework itself. So this is not, so you are just concentrating on your method. Method got invoked here. You are just concentrating on your business logic. Okay. So let me tell you this, like, so the same thing. I have this controller class. Okay. One simple update method, you can change it to post mapping. Okay. Update user. It's calling an update user method. And inside this update user method, this is again a @ component managed by Spring Boot, but I have put @transaction here. So currently I'm not throwing any exception here. Let's say everything got success. Now let's say that I am starting my application. Okay, so I have started my application. Okay, now let's run this. So I am hitting this API update user /API/update user. So now when I hit this, now here if you see, the first control goes into this method invoke within transaction, which is there in transaction aspect support. Here if you see that the transaction interceptor class, right, it extends from transaction aspect support itself. So it's a parent class of the transaction interceptor generally. So this transaction aspect support is nothing but a parent class of transaction interceptor. So here invoke within transaction get invoked. Now currently what it is doing is it is creating a transaction. After that it will it will call our method. Now here if you see our method call. Now you can run your operations, whatever the operation you have to run, update DB, whatever. Now what would happen is once the operations are performed, if everything is success, it will try to commit. So commit successful. Now let's say that instead of all success, I am throwing an exception. New runtime exception. I am throwing some runtime exception. Now let's start an application again. Okay. So now I am hitting the API again. So first it will create a transaction. Once the transaction is begin transaction happen, it will try to invoke our method. Now our method is throwing an exception. So it has been catch. And if you go inside this, what it is doing is it is doing rollback. Okay, so actually it does rollback. So you got it, how internally just by putting @transactional, everything magically works out. So there is nothing magic, everything code is there, but only thing is it is hidden from us. Spring Boot is taking care of it, right? But internally we are still doing the same thing. So now you know how the transaction works. Now we have to understand all these things much better way. What is transaction context? Different types of transaction manager, programmatic and declarative. The propagation, right? Very important. So there are different type of propagation. Isolation level, configure transaction timeout, what is read-only transaction, and many more. So we will go in this depth in next part of this video. I'll see you in the next part of this video, and there we will cover all the remaining part of the transaction annotation. Thank you. Bye.